Alright, so today we're starting 9.3. 9.3 is titled Other Identities. The only ones that we're going to focus on in 9.3 are the double angle identities. And they're all listed on your notes, but I'm going to write them up here.
Would you say that this is like an easier part of the section, or is it like the same?
Part of it's easier, part of it's harder.
Yeah.
So,
Part
So-
she's doing today is easier, but then she's gonna do proofs that there's more proofs that you have to know more formulas, so you might find them harder. So it's half and half. Today's easier though.
okay, so these are our 3 double angle identities. Ladies. Okay, so rather than just giving them to you, we're going to actually prove them. So we're going to prove that sine of 2x actually equals 2 sine x cosine x. So we'll look at that one first. So when we were proving identities before, we had to use other identities that we already had proven, right?
Yes.
So if we're looking at sine of 2x equals 2 sine x cosine x, is there a way that we can rewrite this sine of 2x that we could use one of our previous identities?
Did you do? Yeah. Well, couldn't, cause you know how it's sine x plus y, and you have, you know, the ending part as the y part? Could you just have, like, sine x cosine x, like, as the first part? Does that work out like that, or is that not it?
So, Jasmine, you're kind of on the right track. So you're looking at the addition and subtraction identities.
Yeah.
So is there a way that we could rewrite what's inside our parentheses here as some sort of addition or subtraction?
Sine x plus x.
So we could do it as sine x plus x. So now that should look like the sine addition identity that we know how to expand out. So if we expand that, how does that?
Sine x cosine x. No, cosine y. No.
Well, in this case, you have 2 x's.
Oh yeah, 2 x's.
So you were right.
Plus sine x cosine x.
Right?
Yep.
So then what can we do?
Just combine them.
They're the same thing, so we can combine them. So we have 2 sine x cosine x.
This is gonna be really easy.
I always get confused, like, why you have 2 sine x's and you have 2 cosine x's, but why wouldn't you put 2 cosine x's?
Oh, so 2 sine x, 2 cosine x? So we're multiplying by 2 by the whole thing because
Oh,
this
okay.
is multiplied together and this is multiplied by together, so you have 2 of them.
So you're just putting it in the front?
Yes.
Okay.
Yep, that just goes back to combining like terms, except now your terms are kind of long. Alright, so now we're going to look at cosine 2x. And cosine 2x equals cosine squared x minus sine squared x. So can we not do the same thing that we
Cosine
just
plus
did?
x.
So when we expand the cosine one, what does that one look like?
Cosine x times cosine x minus sine x times x.
So that's again just using our cosine addition identity. So now what do we notice about those terms?
Combine them.
We can combine them, so what we end up with are cosine squared x minus sine squared x. So then the last one that we're going to look at is the tangent. So we have tangent 2x equals 2 tangent x over 1 minus tangent squared x.
So it's just putting it back into the x plus x.
So we're going to put it back into the x plus x again. And how did we expand our tangent addition?
Tan x plus tan x. Divided by 1 minus tan x times tan x.
Ladies, so now what can we do?
Combine them.
Combine like terms again. So that's actually proving that we can use all of these double angle identities. Now for tangent x, we want to take a little bit closer look at tangent x. Can we rewrite tangent as something else?
Sine over cosine?
So we can rewrite it as sine over cosine. So you can do the same thing with the double angles. So you can rewrite your tangent double angle as sine of the double angle over cosine of the double angle. That will become an important fact later on. So I just wanted to make sure that everyone was aware that you can rewrite the tangent one just like we did before. So now I want to take a closer look at the cosine identity that we just came up with, the cosine double angle. So our cosine double angle says cosine of 2x equals cosine squared x minus sine squared x. Thinking about our other identities that we proved already, is there anything that we could rewrite in this formula, in this identity, that we could come up with other identities? So what?
The 1 over cosecant?
So, alright, so you guys are kind of just throwing out ideas, which is good. I'm looking at this side. Are there specific parts of this side that we could rewrite?
Well, identity's adding them, so you can't
Okay, but, so you're thinking about the Pythagorean identity. So what our Pythagorean identity said,
you can't like
cosine squared x plus sine squared x equals what, right? That's what you're talking about?
yeah, but if that for that to work, wouldn't it have to be like negative cosine squared x?
Yeah, so we can't rewrite it exactly like this, but didn't we have other versions of that Pythagorean identity? Didn't we solve for cosine and sine?
Negative cosine squared x equals sine squared x minus 1.
So when we solved for sine squared x, we had 1 minus cosine squared x. And when we solved for cosine squared x,
It was negative cosine.
we had 1 minus sine squared x. So what are you saying, Sam?
Okay, I was thinking if it was sine squared x minus 1.
Oh, okay, so when we made it negative.
Yeah.
Okay. So now looking at those two variations, can we swap them out now?
Make it equal to -1? Or no?
No, so we're not trying to make it equal to -1, we're just trying to get alternate versions of this cosine double angle identity. So other things that we could use that'll still equal this cosine 2x.
1 minus sine squared x minus sine squared x.
So we could substitute something in for this cosine.
Yeah, 1 minus sine squared x.
So 1 minus sine squared x minus sine squared x.
So 1 minus 2 sine x?
So we end up with 1 minus 2 sine squared x. So that is another way of writing cosine of 2x.
What? Isn't there like another?
So is there another one?
Yeah, because if you do it for sine, but would sine have to be negative because there's a minus in front of it?
So, okay, so let's look at that. So again, we have cosine of 2x equals cosine squared x minus sine squared x. So we want to substitute in for sine squared x, right? So we're going to leave our cosine squared x alone,
Distribute the negative?
and we're going to subtract, what does sine squared x equal?
1.
1 minus cosine squared x.
So that's an entire quantity, right? So
Yeah.
we're subtracting that entire quantity. So when we did that, we put parentheses around it.
Okay.
So are you not distributing that negative then?
Well, so
Well, you
now
will.
we're going to distribute the negative.
So it becomes cosine squared x minus 1 plus cosine squared x. Couldn't you do that first just to skip that middleman?
Yes, if you know where we already used on your, I think on your test, you used that negative sine squared x was equal to -1 plus cosine squared x. If you know that, go ahead and skip that. You can, and you would write that as an addition then. But just to make sure that you know exactly where each thing is coming from, I'm showing it to you step by step.
Oh.
But yes, you can do that.
And then one
So-
ninety two cosine squared x minus 1.
So now you get 2 cosine squared x minus 1. And that is also another version of cosine 2x. So altogether we have actually 3 versions for solving cosine of 2x. So now we're actually going to look at example 1. And example 1 should look fairly familiar. So example 1 says if some angle x is between pi and 3 pi over 2, and the cosine of that angle equals -8 over 17. And then we're asked to find the sine of 2x, cosine of 2x, and the tangent of 2x. So this should look kind of like the last 2 problems on your test that you took yesterday. So what did we do to find those things before? What did we have to do before we could find?
Find the other side of the triangle.
So we have to make a triangle, right?
Mm-hmm.
So that's what this inequality is telling us. So what does this inequality tell us? What quadrant does it tell us we're in?
Third.
Tells us that we're in the 3rd quadrant. So we have, like Kara said, we're going to draw a triangle. So we have some angle in the 3rd quadrant. And that's our angle x. Now when you're making your triangles with the coordinate plane, actually draw it in the coordinate plane because that's going to help you label your sides correctly. Because remember, sometimes you're going to have negatives that you need to keep track of. And also, for this one, make sure that you're labeling the correct angle. Because I did have some issues on the test with people labeling the wrong angle. Your angle always comes off of the x-axis. So it's always that rotation off of the x-axis. So make sure you're labeling the correct angle. So if we know we have an angle in the third quadrant, and then we're given cosine x equals negative 8 over 17. What can we do with that negative 8 over 17? So that represents adjacent over hypotenuse. So given our angle, we have our adjacent side and we have our hypotenuse. So now, just like Kara said, we have to find that third side. So this is where we do Pythagorean theorem. So we'll label this as y right now. So we have y squared plus negative 8 squared equals 17 squared. And then just solving this. So what do we get for y? Is it just 15?
Negative 15.
So when we just take the square root, remember that this is plus or minus 15. Now in our case,
It's a negative.
our 15 is negative because we're in that third quadrant and our y values are negative.
So when it comes to the plus or minus for square roots, it's solely going to depend on where the where the measurement is, right?
Yes, that's why they're giving you which quadrant you're in,
Oh, okay.
so that you can figure out if that value is positive or negative.
All right, I get you.
So now that we have our triangle, we can use that to find our sine of 2x. So how do we find the sine of 2x? Or we can just use the identity that we just had. So we have 2 sine x times cosine x. So we're going to have 2. What is sine x? It's negative 15 over 17. And what's our cosine of x?
Negative 8 over 17.
Negative 8 over 17. So you should end up getting $240 over 89. So I want you guys to try the cosine on your own. Because watching me work through it and helping me work through it is one thing, but you need to be able to do it on your own. So I want everyone to do cosine 2x.
Nice.
That makes no sense.
Yeah, I forgot to.
Okay, so,
You got two.
these are my problems, my calculator.
Can I get a calculator for this? Will they be nice numbers on their test?
Or can we use the calculator?
We were saying that you might be able to use like the little like plane calculator. You just won't be given it like a graphic. I'll let you know for sure when we get closer to it. But. All right, so for cosine of 2x, what do we use?
The identity, the cosine squared x minus sine of x.
So you guys want to use the cosine squared x minus sine squared x? You could have just as easily used either of the other two that we developed. They would all give you the same answer. So you have 3 different options. So, what do I do from here?
Plug it in.
What am I plugging in?
Negative 8 over 17 squared.
So I have negative 8 over 17, and I'm squaring that, because it's cosine squared, minus,
Negative 15 over 17 squared.
and I'm squaring that. So you're going to get 64 over 289 minus 225 over 289. And when we simplify our fractions, or combine our fractions, I should say, you get negative 161 over 289. That's what you got? I'm glad you agree with me. Sometimes there's bad math going on here. I need to be checked.
Check yourself.
Okay, so we have, I'm going to just write our sine and our cosine up here just so I have space to do the tangent.
That's a weird answer.
Alright, so I'm going to erase the sine and the cosine. Is everybody,
No.
you still working on the cosine part? Okay.
It is pretty, let's go.
So what color is it?
You're good now? Okay. Alright, so now I want you guys all to find the tangent.
Oh, we're doing it?
Yeah.
Get like a chin print.
So the tangent, what are we doing? I know you guys are probably finishing up, but just so we can get.
Tan X.
So we have 2 tangent x.
Over 1 minus tangent squared.
Is that how everybody is finding the tangent?
Yeah.
Yeah? Okay,
I messed up somewhere.
you messed up somewhere. Okay, so we're gonna have 2 times what's the tangent? So we have negative 15 over negative 8.
Which is 15.
Our negatives will cancel, yes, so we end up with just 15 over 8. And that's over 1 minus negative 15 over negative 8 squared. So for the top, we can actually simplify that, right? Since we're multiplying stuff. The 2 goes into the 8 4 times. So we're actually going to end up on the top with 15 over 4. That's all over 1 minus, squaring that, you have 225 over 64. So we want to combine the bottom. So we're going to multiply this 1 by 64 over 64 to get common denominators. So we end up with 15 over 4 over 64 minus 225 is negative 161. And that's over our 64. So I just combined it like we would after we would have those common denominators.
So we really just got answers to
So now we have a complex fraction. So we have to flip and multiply. So we have 15 over 4 times 64 over negative 161. And what'd you guys get?
It's not reduced, because that's a
So this 4 can go into the 64 16 times. So you're going to have 15 times 16. That's going to give you
Negative 240 over 61.
negative 240 over 161.
Yep.
And that's as reduced as it gets. Sorry, it's hard to see my negative. So you end up with negative 240 over 161. Yeah, Joey.
When it says, when you put the 2 into the negative 15 over negative 8, how does that become positive 15 over 4?
Okay, so remember, Shemaiah told us that this negative over a negative is going to cancel out.
Oh,
So we're going to end up with a positive anyway. Okay? It's a good question, though. Is there an alternate way that we could have done this?
You could have did the sine over cosine.
So we could have just as easily done tangent of 2x equals sine 2x over cosine 2x.
I like that better. Yeah, we should have done that.
So for that one we would have plugged in 240 over 289, and that would have been over our cosine, which is negative 161 over 289. And we would have flipped and multiplied, and you would have gotten that 240 over negative 161. So that's why being able to rewrite that tangent is so important. Wasn't that much easier than doing all of that?
Yeah.
So these are things to keep in mind when you're working on those kind of problems. See you guys.